Welcome back to, welcome back. I am going to explain in this lesson all the string functions that we have in Java. That we have in our 10th grade syllabus. So, all of them, I'm just going to try to explain in one session. So, yeah, without any ado, let's begin. So, this is a default that I have created already. This is what we're going to need for every string function. So comment to explain all the string functions. I made a class. I imported this function, this package java.util for taking input from the user because you will require a string from the user anytime. Then also scan a new object from scanner class. Okay, so let's start. Before we go into any string function, we need to know how to take input from a user, how to take a string input from a user. That's how many people get stuck usually because they don't know how to take an input that is a string from the user. So first you create your string variable, string st. Then what you do, you have to, oops, I thought I could just copy paste. That's the previous program. Now what you have to do is give your output statement. You can say enter a string. Now, when taking a string for like for an input, always remember you have to remember your object that you give. Some people do forget their objects and yeah, they make mistakes. So remember what your object. It can be in, it can be OB. I love to keep it as in. So now what you do is you take the input from the user. How do you do it? St is equal to in dot next in. Did you catch that? Yes, it's not going to be int. See, some people they make mistakes. Now they're thinking like there are some people they're a little bit absent-minded. What they do, they instead of doing in dot next in dot next, what they do, they just do this int. You can't do that for a string variable. You have to always do in dot next if it is a line, and if it has any spaces, then you go with a line in dot next line. If it has any spaces or anything, if it's like a word, then just in dot next. If it's like a line, or if it's like line with spaces, technically, then you go with in dot line. But right now we just want a word, so in dot next. Now what you can do is you can display that word, of course. The heck? Sorry. You kidding with me right now? Where do these things even come from? Yeah. You kidding with me? Yeah, sorry guys, I just rookie mistake. Okay, what I did here, I put an output statement saying that your string is this. If I compile and if I run the program, oh no, gotta reset my output output box as well. Okay, anyways, enter a string. Let's enter blue J. See, you entered a string. Your string is blue J, and it says your string is blue J. So our program works. That was a little bit intro. Okay. Now for people who want revision, yeah, sure, I'll do some revision. Wait, let me just close blue J one sec. Oh, this is a brilliant paper. If you want, you can. I can send it to you guys. I don't know if you want it. Otherwise, if you have it, then yeah. Gosh, kind of difficult to use on Mac. Okay, so then you have your string, right? Now, now you want to start with your function. Let's just start with the first function that is int len. Now this is a string function. Of course, it's not complete yet, but it's a string function. What it does technically, int length, or let's say if you initialize another variable that is int a, suppose. Now, what you do is you take a is equal to you have your string st and len dot len. There we go. Now, what do you do? What is done here? Technically, what does dot length mean? Dot length means that if you have a string st, which you have it here, st, now dot length will find the length or like the number of uh, vowel, I mean not number of letters that are there in your string technically. If your string is blue jay, it has 5 letters. So what dot length will do? Dot length will just, you know, count the number of letters and display them. So A has a value of 5. If ST is blue jay, if I enter blue jay over here, then That's 5 letters. So A has a value of 5. I just showed you once. So I'll display A star. Let's see. Yeah, enter a string. I'm gonna enter blue. Blue jay. If I enter the string, forward and go. I entered a string, blue jay, and it gave me, since it has 5 letters, 1, 2, 3, 4, 5. So it's going to give me the value of A, which is the length of the string, is 5. I hope you understood this function quite easy, and it's also very helpful whenever you need to do any loop or anything. You're gonna have to use this function over here. Why? Because if you're gonna have to like probably check within a string how many vowels are there, how many consonants are there within that string, then you would require a loop. For that loop, you need to know, the loop needs to know how many times it has to be run. So this function will help you understand, or will help the loop understand how many times it should be run. Because the number of consonants, or if you have to find the number of vowels or number of consonants, you need to know the number of letters that are there in the string. So you run that many times, the number of letters. Yeah, but we're not going into that right yet. Let's go on with the next function. The next function is car at int index. And now this is not a function yet, it's a display type function because I'm getting errors. So what does this function actually do? This function helps, like if you have a string in front of you, then if you put this function in front of the string, if any string, you put this function next to it, this function will find you the desired letter that you want. Int index means any number actually from any number from the string. Because the string has 5 letters, and you want to see the third letter. So what we'll do? Just press. You have to switch this word 3, and then what will give you? It'll give you the third letter. So imagine you have 5 letter blue jay, and you want to know the third letter. So you have to pop this function. You have to pop out this function, and you will get the third letter is U. So let's just go with it once. Let's see how it's done. Char. I have to initialize a variable. Char G. Let's say for this function you have to always use a character. Okay, because it's a character function type. Character and like a string mix function. So you have to always use a character. Car. Now to use the function, you can say C is equal to SD dot car and oops. I can say any index, okay, third index, okay, fourth index, okay, fifth index. I'll go with third. And then what you can do, then you can just display your letter that you get. So technically, just run it and I'll show you. Okay, enter the string. Let's enter blue jay once again. Now you can see here. Now it gives you E. You must be wondering, it should give you U. But why did it not give you U? It gave you E. Now that's a scam. It's not actually. See, we start in normal human life. We start counting from here. One, two, three, four, five. Okay, we think this is a five-letter word, so we should start counting from one. But in a computer also values zero. So what the computer does, the computer doesn't start counting from one, it starts counting from zero. So it'll not go like one, two, three, four, five. It'll go like zero, one, two, three, four. So you have to think it according to the computer, not according to your brain. Sorry. So according to this, you can see E. E over here looks like the fourth letter, but according to the computer, zero, one, two, three. For the computer, E is letter three, so it displayed E. Okay, so think clockwise, always think according to the computer. Even in strings, even in arrays, they always start from zero, not from one. So be careful. Always, and always start from zero whenever you're calculating a string or anything. So I hope you understood this function. It's just finding a letter from the string that you need. Let me head on to the next one. Next one is int uh, index of uh, shit. Now what this function technically means, it just means that what you're doing over here is you, I mean, it's just the opposite of character add. Okay, this function is just the opposite of this function that you just did right now. These two functions are exact opposites of each other. I'll tell you why. Okay. So you see in character add, you had to find the like you have to give the letter, the number to the computer. The computer would find you the letter within the string. But in index of, what you have to do here is that you will give the computer a letter of your string, and the computer will find it in your string, that specific letter you gave, and then it will see the index number and will give you the index number of that letter. Now to not complicate things, let me just run it once. Let's initialize a variable p, integer p, okay? Now because it's an integer, because like you will get a number value in return, that's why you need an integer. If you're getting a character value, you need a char. And if you're getting a string value in return, then you need a string. Now, p is equal to se dot index of. Now, always put a character in this. I don't know what do you call it? Colon, single colon. Put them in single colons. I don't know what you really call this. Single apostrophes, probably. Put them in apostrophes like this. Only one apostrophe. For string, you have to put it in double apostrophes. But for character, one apostrophe. Now, if you're going for blue jay, so then let's go for the character U. Then what we do is Okay, I will just displaying the index. Enter the string, enter dimension. As you can see, you wanted the letter U, right? That's what we entered there. If you want the letter U, the computer went and searched for U. It searched for the first one, 0, 1, 2. This is what we want. So it gave the index number of this character. That is 2. Okay, so hope you understood that. We can on. We need to complete this one a bit faster because the previous video took a little bit long time, 2 hours. And I don't have 2 hours. I just have like 1 hour or less than that. Let's, let's just try completing this at the fastest. Okay. Okay. Next, what we have is another variation of index. Now I'll show you again. Again, we it's another variation of the character of the function we just now did. It's another variation. So p is equal to st dot index of sorry. Over here, we enter a string, let's say p. Now you enter a string. Now you must be wondering what is different here? Not yet. If I just enter this, boom, mind blowing difference. Now you understand. Yeah, now you think like, why did I do this? What is the necessity? What is the purpose of this? Now let me show you. If this will again, this is nothing different. It will give you an index number only, like how the previous one gave us. This one is a little bit different though. I'll show you one second. Give me one second. Enter a string. Now I'm going to enter a different string this time. Yeah, you know, Malayalam. Now that is the different string. Now you might wonder why I entered this string. Okay. Before I enter this string, notice that there are one, two, three, and four A's in the string. There are four. Okay. Now you notice that in my character, in my function, I've also given a four. Now you see here, once I enter the string, it's giving me an index number of 5. Now you must be wondering, wait, 0, 1. Shouldn't it give us a 1? Because that's like the nearest alphabet, and that's what we want. We want A. We want index number of A, isn't it? But not really. I entered there A, yes. But over there, I also entered, okay, what the heck? Over here, I entered 4 as well. So, what does this 4 mean? 4 is like a starting index number. Over here, 4 means that after the fourth A, you're going to find the index for me. So, first A, second A, third A, fourth A. Okay. Now, if you see the index 0, 1, 2, 3, 4, 5. Okay. Not four A's actually. After the fourth index, you have to find the next nearest A for me. This is like fourth index is 0, 1, 2, 3, 4. Y is on the fourth index, right? Now, after that, I want you to find the index number of the nearest A that you can see. Is it this one or is it this one? Well, let's not play Dora the Explorer. It's of course this one. Now you can see what is the index number of this character. It is 0, 1, 2, 3, 4, 5. That's why the computer gave 5. That's not it different. Sorry, throat. If I run it differently now, okay, what if I say 6? After the sixth index, you give me the index number of the nearest A. Let's see what it gives me. Now give me 7. Why? I want the nearest A value after the sixth index. So 1, 2, 3, 4. I mean, sorry, what am I doing? 0, 1, 2, 3, 4, 5, and 6. This is the sixth index. So I want the index of the letter A on the next one, which is this one. This one is the seventh index, and that's what I want. So that's what the computer gives 7. So that's nice. That's nice. Let's head on to the next one. Next one is also a bit interesting. Again with index. Here what you do is here we introduce a new character, a new function, but nearly similar purpose, which is the sd dot last sd dot last index. Now look over here, the slight difference. Every after the dot, every letter is in lowercase. You can see here, every letter is in lowercase. But after that, introduction of any new word such as index becomes uppercase. That was not the case in the before function, in the previous function. In the previous function, I was small because I was immediately after the dot. Your L is after the dot, that's why L is small. But after introducing every new word, the first letter becomes big. So it can like differentiate between these two words. So is F. Now this is a bit different function. What I mean, similar purpose of course. Now again, I give this function to find me the index of A. Okay. Now before I run this function, what this function means is that the last index of means the last letter A. Give me the index of the last A, not the first A, not the middle A, not the third A. I want the last A. Okay? The index of the last A, you have to give me its index. So let me here. Okay, let's enter again. See, you can see The not the first A, the last A is 7. So how? Let me calculate. 0, 1, 2, 3, 4, 5, 6, 7. That is the index of the last day. So that's going to give me 7. Okay, easy. Let's head on with the next function. Now the next function is different, so it require a bit different stuff. Next function will require another string. Yes, we're getting a buddy for our new string friend. Listen with me. Now this function is different. How? What is this function going to do? Now let's say let's not give an enter system dot out. Let's print enter. Let's just make this a comment for now. Okay, and let's remove this as well. I'm giving a fixed value to this string. Let's give this string a fixed value. Let's name it computer. Let's give this string the value of computer. Okay. Now you can see over here, computer. Now what I'm going to do, I'm going to introduce a new function called p is equal to st dot substring within bracket this tree. Now you must be wondering what a substring is. Substring is technically if you give a substring of this letter, after this letter, whatever word you get, that word is only going to be the value of this p. Such as you say substring of 3. So let's count the index 0, 1, 2, 3. This is the third index. So from this index to the last index, that is r, this entire word is going to be there, is going to be the value of this new string, and the rest that was not counted is going to be discarded. Okay, so let me just run it for you. Bye. Okay, so we wanted the word that is after the third string. So what we got? We got computer. We entered computer. We want the word after the third string. We got computer. Now you think over here many people do get confused between what is the third string and what is all that and stuff like that. Remember here, if you're getting confused like this, okay, you don't know what to do, just remember, then at that time, do not go with computer counting. Count with your brain. Count like 1, 2, 3, 4, 5, 6, 7, 8. Here you can see 1, 2, 3. If you count normally, then M is the third index. So remove M and remove O, remove C, and whatever rest you get is your word. Okay? What a computer does, if the computer starts from 0, so it goes with 0, 1, 2, 3, then it enters the rest of the word neuter, but also enters P because it will also enter the index that you have given. Okay? But if you find that confusing, just go with a normal counting. Starts with M and remove everything behind and M as well and enter or remember whatever is in front of your digit, that is what is going to get added or valued or whatever. Okay? A similar function we have that is substring 3 comma that's it. Right. This is a similar function. Why? because in this function, it's a similar thing, but except you happen to, let's say, if you're counting normally, you take till m, okay, you get the rest of the word tutor, but over here, if you start counting again, normal counting, okay, normal counting, one, two, three, four, five, six, seven, eight, okay. So this is the third character, this is the fourth, this is the fifth, and this is the sixth. Okay, let's not do normal counting. Let's go with computer counting. So that's zero, one, two, three, four, and five. So that means I want the string value that is only from 3 to 5. Except for that, I don't want anything else. Remove com, remove all. I just want put. So that is what it is. From 3 to 5. Yes, 3 to 5. That is put. It's technically you're cutting. Imagine you're having a scissors in your hand and you have a long strip in front of you. Okay, long strip of paper. Then if you have only three over here, that means you have to only cut one side of that paper, slip of paper. And if you have like two digits in front of you, that means always remember that you have to cut two sides of that slip of paper. Okay, so I hope it's understood. I will just run it once. Okay, give me poo. That's a bit weird. Oh, of course, will give me poo. What am I doing? Oh yeah, I thought I gave six. So if I want put, to be honest, if I want put, this is first, this is second, this is third, this is fourth. If you're doing normal human counting, fifth, and this is sixth. So fourth to sixth, that is what I want here. If you're doing normal human counting, if you're doing computer counting, zero, one, two, three, four, five. Okay, zero, one, two, three, four, five. This is three, and this is five. But this over here is six. So I want the substring to cut the string for me into one part where one part is three, index is three, three should not be included. Another part is six. Six over here. If you're doing normal human counting, six over here is not included. But if you're doing computer counting, then three is not included, but six is included. Always remember that. Did I just say the opposite? Yeah, I said the opposite. Sorry. If you're doing computer counting, three is included. Zero, one, two, three. Three is included. The first digit is included. And the second digit, which is four, five, six. Six is not included. If you're doing normal human counting, then three is not included, but six is included. But always go for computer counting. That's more easier. So three is included, six is not included. First digit is always included, second digit is not included. Okay. Now let me use another form of. What if I only want com? I don't want this digit. I just want com. Okay, com. I just want this four letters. Com. Okay. How will I get it? Let's say this starts from zero. So I won't want zero over here. And now zero, one, two. 3, 4. I'm gonna have to extend it till here. 4. Now let's see if it gives me comp. Okay. There we go. It gave me. So you can see over here, got comp. So like that, you can actually cut your string with a piece of scissors, pair of scissors, how many times you require. Up to you. Sorry. The next function that we're going to go to is the easiest out of all of these functions. That is going to be the lowercase. P is equal to st dot to lower. Lower and case are two different words, so remember that. So they should be separated by a capital letter, both of them. Okay? Now, two lowercase technically just means that if you have an uppercase word, you're gonna complete. You're gonna just what am I saying? You're gonna convert it into lowercase. Okay, that's it. So I have this uppercase word. I'm gonna convert it into lowercase. So this should give me the lowercase of that word. See, computer, which was in uppercase in my program, is now in lowercase as an output. Now, if I just make it a little bit different, let's say, let's put something in already lowercase. Let's put U in lowercase. Now you see over here, it doesn't matter for the computer. Computer won't see this as an error. U is already in lowercase, so you will remain in lowercase, and everything else will change from uppercase to lowercase. I hope that's understood. Okay, we shall go to the next one. That is uppercase. Now you have a string that is completely in lowercase. And what you do, you just use the uppercase function. This is the uppercase function to uppercase. Always remember that it has a two, just don't write uppercase. Only it has a two uppercase. So you always remember that. So it's just going to give me the uppercase of that word. Boom, 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 boom. See, the lowercase becomes the uppercase of that word. Okay? This is kind of self-explanatory. So I shall proceed. We have gosh, we have like at least 10 more functions to go with. We just completely like I don't know what 8. We have 10 more to go. Guys, no bro. Okay. Upon with the next function. Next function is my old friend replace function. Now, replace function technically means you're replacing one letter with another letter of a string. You're replacing one letter with another letter of a string, such as E is equal to. You have computer over here, so let's use that only. Let's say, let's replace vowels. Let's say, sorry. This is our word. Now we're gonna, now this doesn't look complete, right? So what we're gonna do, we're gonna fill in the gaps with the vowel that is required to make it a meaningful word, that is computer. Uh, so we're gonna use the replace function for this. Now the replace function, what we're going to do is it can replace a string, it can also replace a l- letter. So for now we're going with letters. We want to replace the letter X with the letter. First one we want to replace it with O, right? So that's what we're going to do. Com. Now always remember the letter to be replaced is at first, and the letter that you want to replace it with is at the second. So I want to replace X with O. So X comes first, O comes second. Always remember that. So like this, I think I'm going to I just do this. Will that work? Oh yes, I can. Oh, but no. I think I have an idea. Let's put Y over here and let's put Z over here. Oh no, let's not. Oh no, we can actually. So P is equal to, we're going to replace these strings, control C. Now you're going to have to redo this. Okay. Now here, you replaced X with O. You want to replace Y with U. So you're going to have to do that. And here you want to replace Z with E. And you must be wondering, why can't I just directly do it here? That must be so easier, bro. But actually, in Java, many functions are required, many loops you have where you do not know what string you have. You do not have a fixed string. The user will give you a string and you do not know what the string is. Maybe the user can make spelling mistakes in that string. So this function is required in that case to replace it if there are any spelling mistakes or if there's, whoa, I saw a coil out of my window. And if there are any spelling mistakes or anything. So that's why you use this function. Okay. So then you're gonna have to put uh, now let's run this. Now you can see over here what this did technically is it didn't do what we wanted to do. It only replaced Z with E. It did not replace Y. It did not replace X. And now why is that? That is because that is the last thing we did. Over here, we did do all of this, but the computer only takes the last thing that we did. That is what the computer will take. Such as if this was the last thing, where this is the last thing, then compile. Oh my God. Bro, it's been 1 hour already. How, man? How am I that slow? Yeah, now you can see over here, it has replaced Y with U. So what it does, technically, the computer cannot uh, do many things at once. It will only do one thing at a time. I mean, I know the computer is famous for doing many things at once, but that is when you have an expert program or code. Okay, with this program, you can only replace one thing at a time. Okay, because P can only take one value, it cannot take all values. That's why you can only do either one of them. So be careful with this. Let's head on to the next thing. Next one is a bit similar to this one. In this one, what we are going to do is we're going to have a big word. Okay, let's say, let's take a tongue twister. She sells the shells on the seashore. Seashells on the seashore. Okay, in this one, what I want to do here, now you can now you can replace words as well. Not only letters but also words. I can replace the letter E probably over here. Well, let me just try that once. I can replace E with X. Oh yeah, it's also displayed now. See how conveniently just converted every E that was there. She sells, she sells on the so every E has been converted to by X or whatever letter we can give. So that is very convenient. It's not like sometimes if you don't want to, if you have a big type of very big kind of string that you have, and you don't want to like do all of that, you don't want to convert all of that. So what do? You just use this replace function. Now, if you want to replace these functions, you want to use this with words. Yeah. Uh, let's say she says, let's convert this. Say she says, if you see here, this sentence is slightly wrong. She sells tea in the seashore. That is wrong. Now what I want to do here, let's convert C, always strings go in double bracket. C, let's let's replace it to uh, toy. Okay. So C sells C in the C store will become C sells toy in the toy store. So this she sells a toy in the toy store. I can see over here. She sells a toy in the toy store. Earlier it was C, now it became toy. So that's simple. That's just you're replacing strings with another string. Now let's head on to the next one. Next one is a similar function. This one is replacing. Next one is joining. We always have cutting, we have replacing, we have joining, we have breaking, we have finding, we have searching. Now we're going to use the joining one. Okay. Now let's use a different string for this. Let's use, let's use two strings. Yeah. String one, we'll say Sam. And then you have string st2, which says e. Okay. Now you want to oh wait, sorry. You want to join these two strings so you can get a name out of them. Okay. So what you're gonna do is you're gonna use the concat function. And you must think, what the heck is this, man? I came here for computer class, not a grammar class. So yes, concat is a function. Concat technically means to join. Just join two things, two or more things. But I said two things. So if you have these two words over here, you can use the concat function to join these two words. How are you going to do that? Good question. So you have, it's easy. It's not like st comma st2. No, don't do that. Don't do that. Since you already have st over here, as simply what you can do, you can just write st2. Concat is like a glue. Okay, remember it as a glue. So this is one cardboard piece. This is another cardboard piece. You're going to use the glue and you're going to join these two cardboard pieces and you're going to get this combined together. Let's display it. See, I had two strings. One was Sam, the other one was Eek. I used the concat, and then I joined them together. I got Sam Eek. So that is again simple. These functions are very easy to understand, really. Once you get the hang of them. So once I'm done with these functions, I'll probably upload another video where I do some programs based on these functions. So that'll be much more helpful, I hope. So you guys can refer to these functions. You can see, you can really know them, and then you can see the programs for them. Okay, next we go to a very like a little bit complicated function here. Let me just erase all of this. Okay, next function that we have is a little bit slightly complex function, but also an easy function. The next function is boolean equals string st. This is a very complex function, but also easy to understand. Boolean, technically, whenever you hear the word Boolean, it's always a true and false. It's always true and false, okay? Now, what it does, it technically equals means it's to compare. Boolean is true or false, equals is to compare. So what are we comparing? We're comparing two or more strings over here. Okay. Now, you must be wondering how is that going to happen? Well, it's kind of easy. What are you going to do here? You're going to have to make some strings. A boolean is a data type. Don't use it in your string type. So if you have two strings, we name one here st2, st2. Let's say st2 is equal to Sam. Okay? st2 is Sam. Now you must be wondering what is going on. Hold up, man. Let's introduce another string as well. st3. st3 is equal to. Now we're going to use that function over here. We're going to use it similar to how we use the concat function. We're going to use st1 and dot equals. Oh, we don't have st1 now. Dot equals in bracket st2. Oh yeah, it's a boolean, no? Sorry, God. It's a boolean data type, so you can't use it as a string. Yes. Now you must be wondering what is going on. Let me explain. I took two strings here, Sam and Sam. Okay. Now what I'm doing over here is I used a boolean. Boolean always is true and false. So it only has two fixed values, true or false. It's not fixed, technically it's a random, but it has two values. So what is it doing over here? It's taking the first string, st, that is Sam, and it's equals, that is, it's comparing this first string to the second string, that is also Sam. Okay. Now what it's going to do, if it is equal, then it will give true. If it is not equal, it will give false. Okay, now let's just run it once. Before we run it though, we have to give a sentence because it won't just give true or false. I mean, if you just run it like this, I mean, it could give true or false, yes, but we do want, like, we want to know a bit deeper. Like, okay, fine. Oh wait, before we do so, I have to display the sp3 compile. See, true. Now what it means that because they both strings are the same, that's why it gave me true. Okay, that's why it gave me true. Now, if I said, I can also use this as an if or else case, such as if st3 is equal to true, then I can say they are the same. Now, same thing if I gave, what the- same thing if I gave here, else. They are not the same. Now, if this is true, means if they are equal, then you can print they are the same. If this is not equal, or if it is false, then you have to print they are not the same. It's the same thing technically. All you're using is the if or else case function, whatever you call it. See, they are the same. Now you must be thinking that what if I put this as lowercase instead of uppercase. Mhm. No, sorry, my mom came in. Yeah, where was I? Yeah. Now if I use lowercase over here, you must be wondering, what will it do? Let's check it out. Will it give me they are not the same, or will it give me they are the same? Will it give me they are not the same? Because why? As you have heard from ninth grade, I suppose, you must be knowing that Java is case sensitive. That means that if Java case sensitive means that uppercase and lowercase matters in Java. Okay, you need to know whether it is an uppercase or whether it is a lowercase. And respectively, you need to give your value. Okay, so you have to, because Java treats lowercase and Java treats uppercase differently. Okay, now this can be a problem for many programs. So the solution to this problem is one easy answer. That is, you have to use another function. Okay. The second function that we're going to use is, let's introduce another string, st1. st1 equals to st st dot equals ignore key, and within the bracket st2. Okay, equals to ignore case st2. Now what you're doing over here you're doing is you are ignoring the case. Oh yeah, you didn't even declare st1. Now st1 is actually equals ignore case is a boolean data type. I mean, it'll give you false or true. Okay. So now, if I can say Equals ignore case is the same as this kind of equals function. Is this thing is nearly the same as this thing. The only difference is that this function will ignore the case. It'll ignore the uppercase and the lowercase. Means for this function, both of these strings look the same. But for this function, both of them look different. So now if I give st1 over here, okay, that means come ignore the case. Just ignore the case, man. You don't need to look at the case. They are the same. Why? Because it ignores the case. Unless the letters are different, everything else will remain the same. Okay, so if it was not Sam, it was what E, then it will give you a different, it will give you false. Not because of the case, but because of the letters. Since the letters are not the same, then why will it give you that? Why will it say that these are the same thing? It will not say it's the same thing. Say it's a different thing. Okay. Next, we go on to, I don't know if I should do string buffer. String buffer, we don't really get that in your exams very much. Some can come, like one or two can come, but not all. All is not going to come. I'm just gonna stop after one, two, three, four, five, six. Six more functions, and that's it. That's the end, man. That's the end. I don't know how long has this been recording for, but I hope that's not too long. Okay, so I head on to the next function. I hope you understood. I hope you understood this one. Next function over here, what we have to do, actually we do need an STP. Next function over here is the compare to, is that lowercase or the uppercase? Oh, sorry, compare to function. What does this function do now? This function is different. Why? Because this is not an year. You're not comparing here. I mean, yes, you're comparing here technically, but in a different method. Here, many people do get confused most of the time. I think I also make it confused while explaining, but let's just try this one. This is when you're comparing two different strings, st and st2, okay? And then you're going to look at the ASCII values. I hope you know what ASCII values are. ASCII values are like every letter has a different ASCII value, technically. Letter A has from capital A to capital Z, we have ASCII value of 65 to 91, I suppose. I think so, hopefully 65 to 91. And for smaller letters, we have 97 to 121. I don't remember the ASCII values really that much, but you can go through them. Yeah, why not? Man, I don't think so I can find it right now. You can go through them, of course. Do remember them. It will come in your exam, I guarantee. So now let's use this. Okay, now blabber. Let's use this. Let's say ST is equal to caps. Let's go for caps. Computer. And then you have ST2 is equal to science. Now what you're doing over here technically When you use now the compare to function is an integer function. You have to always use an int. Let's name integer and let's take a variable num. Now what are you going to do? You're going to compare them. So again, format you're going to use. When you're comparing two strings, you always have to put the first string and the second string in this manner. First string, function, second string. Okay. Now in this function, what it does technically, it's going to give you a number value. Okay. Now it's going to be on the basis of your ASCII values. Sorry. It's going to give you on the basis of your ASCII values. Now in the above example, the variable num will be assigned to a negative value. Why? Because of the difference between the ASCII values of the first character C and of the first string and the second character, I mean, the first character of the second string S. These both are different. They're not the same. That's why it's going to give you a different ASCII value. It's going to give you a different number. That's why. This shows that the this string over here is smaller than this string. Why? Now you must be thinking that, huh? How is that possible? This string has more letters. This string has less letters. No, that's not. It doesn't go like that. When you use the compare to function, it's always like C and S. It's gonna check the first two letters. Okay, it's always gonna check the first two letters. So C in the terms of ASCII value, C is I think has a value of 60, 60, A 65, B 66, C is 67. Okay. And S has probably a much greater value. It's like 70 something, 75, 76, uh, 80, 82, something like that. So what happens is you take the ASCII value of S, you subtract it with the ASCII value of C. It's always the first digit, not first two digits, first digit. And now whatever answer you get, so if you're doing S, capital S minus capital C, ASCII values, that'll be like 83 minus 67. Whatever answer you get, that will be the value of this num. Okay. Now you must be thinking, oh my God, what the heck? That's so complex, man. But chill, 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 chill. We are doing complex language, things will become complex. Also, one more thing, the function compared to performs comparison between the lexicographic analysis of the strings. Like lexicographic means ASCII codes. Okay. Okay. They can give you in this exam probably what is lexicographic. I'm not sure if they will. That's kind of like a bit out of syllabus, but still, just remember, just know what it is. It's an ASCII chart stuff. Okay. Like searching a word in a dictionary. That's what it is. So it results in the difference of the ASCII values between the corresponding characters. Now, if the ASCII values of the characters are the same throughout the strings, like all of the strings have the same ASCII values, okay, then both the strings are declared to return the same and it will return zero. Why? Because now see, if I entered here C, the science, the science. Now over here, C is similar to C. Now you must think, okay, job is done. Give me zero. I mean, like you must be thinking, capital C has 67 value, and this capital C also has 67 value. So 67 minus 67, it will give you zero. But that's not done yet. After checking the first digit, after checking the first letter, it will start checking the next letter. which is O, my dear. O and C. Okay. It'll keep on checking like this. It'll keep on checking from the second letter, third letter, fourth letter, fifth letter. Okay. If they're same, they will keep on going on. If they're different, they'll subtract it and give you a value. So that is how it is gonna go. So if the entire thing both are computer, then it is going to give you different. I mean, it's going to give you zero. Why? Because same number minus same number gives you zero. That's obvious. Right. Now this is going to give you a negative number. Why? Because not because you're subtracting 82 minus wait, is it 82? 87, 77. I think it's 83. Yes, 83. So 80, it's not 83 minus uh 67. Why? Because here what you're doing ST compared to ST2. ST compared to ST2. So when you're doing ST, it is 67, and when you're doing ST2, it is 83. So that means you're going to do 67 minus 83, which is going to give you minus 16, negative number. If you do ST2 and ST1, then it's going to give you a positive number, which is 16 plus 16. Okay, but let's just check this one. Oh, what did I do wrong? Oh, there's no value like ST1. Also, I forgot to initialize, I mean, display the value. No, that is what that's what we want to display. See, minus 16. Simple. Now, if I put over here ST2, and if I put over here ST1, so now what it's going to do? It's going to make it positive because it's 87 now. 83 minus 67. Oh, compile this only now. See? 16. Now, you must be thinking, okay, that's nice. What if I give computa? Now you can see over here, this is different. You can see over here, everything is nearly the same, except these two digits. Okay, now let's see what it gives me. This is 65, this is 70. These 70, this is 65. According to my guess, it should give me uh minus 5. Oh, minus 4. So E is 79 actually. So minus 4. And like that, you can play with these kind of strings, you can play with this function. It's very fun when you understand it, and you can actually do a lot of things. This is very helpful in programs as well. Most of the time, it's very helpful in programs. So yeah, use it however you like. Now, if I gave computer, both strings are now computer computer. If I now this is different case. Okay, this is different scenario where if I give both of them are computer and computer, now what do you think will be the answer? Well, if you're thinking zero, that's right. It will give you zero. But now, what if I did this? Will this give you zero? Now remember the time when I said that Java is case sensitive. That means again, this will not give you zero. Why? Because in Java, capital C and small c have different values. Capital C is 67, but small c is not 67. Small c is 90, 97, 89. This is 99, I think. It'll probably give us 99. So 99, the first string which is 67 minus 99, which will give you 39, 32 minus 32. Yes, minus 32. See? So now you must be thinking that what if I wanted 0? I don't want, I just want this to be capital and this to be in uppercase and this to be in lowercase. But I want the answer to be 0. I don't want it to be minus 32. So what will you do in that case? In that case, what you have to do is simple. Like how we used in the previous function, we used boolean. Oh my God, sorry guys. My other came. That was a bit scary. Sorry. Yeah. In the previous function, we used boolean, right? Boolean equals ignore case, if I'm not wrong. So again, over here, compare will also have two, where you already have two now. Two ignore case. This is the solution for all your uppercase and lowercase problems. Now, once you do this, it'll forget the it'll forget the lowercase and the uppercase. It'll just give you a big zero. Okay. So you wanna see it? Let's see it. See? Zero. This is because this function just ignores all the cases. It will remove the case and it'll compare it for you and it'll remove the case. Simple. Now that is done with compare to function. I hope you understood this function. I've tried my best to make you understand this. It's also very kind of easy once you get it. If you did not understand this, then you can, I don't know, I think the comment section will be off. I don't know how to activate the comment section, but if you did not understand this function, you can reach out to me through my number, I guess. Yeah, I think I'll be posting my number in my description box. If you you get some doubts or if you feel if you do not understand this, you can reach out to me. I can help you personally. Let's go to the next string, next function. Next function we have, let's take it as next function is very easy. If you have a string, now this person, let's say this person gave me a string, but there's a lot of space. There's a lots of space. And then you have your string. Okay, now what to do, man? I don't want all the space. In case if I'm like doing a loop or if I'm doing a function where I'm trying to count the number of digits or letters, okay, in this string, then the loop will also count these white letters also. So this not white actually, this empty letters, this empty section it will count. So I don't want it to do that. I just want it to count this. So there's an easy solution to that as well. What we have to do, we just have to use the trim function. One sec. So st dot trim. That's it. st2 st2. Now, what it technically does, the trim function is to remove all the white space, all of it. Remove it. Just remove all the white space. White space means all the empty space, all this bracket space that you see now, like all this, like, what do you call it? Empty space. Like this empty space. Remember, it's empty space. All this empty space that you see, it will remove all that empty space using the trim function. So it's simple. See, only computer. Now, what if I gave some space over here? What I give some space over here, space over here, and space over here as well. What will it do now? Let's check it out. Now you can see over here, this is now the space after it really will not matter. It will be trimmed as well. The space before it will also be trimmed, but the space in the center, it will not be trimmed. So remember that it will not be trimmed. Why? Because the computer thinks that the space in the center is the part of your string. Usually, when we write a sentence, the computer, we want to keep the space between two words. We want to keep the space between two words. That's why the computer thinks that if you do not keep the space between two words, it will be meaningless. Okay, that's why you have to keep the space between two words, and that's why the trim will only remove the space after it, before it, but not in the middle of it. In the middle, whatever space is there, that will be kept. Okay, we go on with the next last four functions. I hope you understood this one. This one is not that complex. It's just you have to remove any empty space using trim function. Next one we have is two Boolean functions. First Boolean is actually the next one is a confirmatory type test. Okay. So we have string is equal to I love to do computer. I love to do computer. Okay, okay, let's just keep it like this. Now, what we have to do here is technically a bit confirmatory test. Okay, now technically this function, the next function is a Boolean function, Boolean, and the function is ends with. That's the function technically. So what this function means is that you give a computer to a word. Okay, and then now the computer checks if that word is there at the end of this string. If that word is there at the end of the string, the computer will enter true. If it is not there, the computer enter false. So let's just quickly do this. Uh, Boolean can actually, yeah, let's just go with Boolean st2. Let's see how I do use over here. Is equal to st dot ends with uh, computer. Now what this does, it will give me a Boolean value if it will give me a true or false value if the function ends with the word computer. So it should give me true or false. At this most case, it should give me true only at the most. See, true. That's because what I just did technically was I just confirmed whether the computer word was there at the end or not. That's it. Now I'll give you a small quick question. Is this going to be validated? What if I do this? Will that give me a true or false? Let's see. You have one chance. You can enter your answer right now. True or false? Let's say that is a true. Sorry, this one. That is true. Now you might be thinking, if you people who said true, they're right now proud on themselves. I'm quite sure. People who said false, they'll be like, what? How's that possible? Now, see, the TER is actually there in this last word. Whatever is there in the last sentence, it can be anything. It can be also this, can be this. It doesn't matter. It just has to be something that is there. If it is there, then that will be true. Why? Because it's there. TER is there over here. That's why they said true. I hope most of you got that correct. Now, what if I did this? What if I said uh love? What if it ends? One second. Give me 1 second, guys. Give me one. Yeah, okay, I'm back. So technically, what my father came in. So technically, one second. Goodbye, guys.